Baik, Assalamualaikum warahmatullahi wabarakatuh. In this video, we will look into this topic. We will try to discuss on this topic, which is the radioactive decay. Okay, so radioactive decay, we had learned it about radioactive decay in our Form 2. Okay, if you still remember, in our Form 2, we had learned a little bit about radioactive decay, where you had learned what is the type of decay. We have alpha, beta, and gamma, and then what are the characteristics of those decays, alpha, beta, and gamma, how you can differentiate between alpha, beta, and gamma decay. Okay, so for this semester, we look into this topic. There are a few additional info that you need to know, which will be included in your SPM. Okay, so for the first one, let's go through our notes here. Explain with example the decay equation for alpha, beta, and gamma. Okay, so for this subtopic, we will try to explain the equation through the equation. Okay, we look into the equation alpha, beta, and gamma. Before this, in your form 2, you just learn about alpha, beta, and gamma, and then the characteristic of the radiation from alpha, beta, and gamma. And then for this subtopic, we look into the equation. Maybe some of you will think that it is very easy because you had learned it in your chemistry. You had learned about the chemical equation. Okay, so there is not much difference between these equation lah. Lebih kurang sama. Okay, intro. While you are in Form 3, okay, ni semua dia dah belajar. So we have three type of radiation, alpha, beta, and gamma. So it just a quick revision. Alpha, which is equivalent to the helium of nucleus, and then beta, it is actually the electron. Okay, this is not the electron that you learn in your chemistry, which is orbiting the nucleus. This is the electron emitted from the nucleus itself, where the neutron, one of the neutron, will decay into one proton and one electron. And of course there is antineutrino dan sebagainya lah. So itu tak perlu kita tahu. Okay, for your part, you just need to know this electron is coming from the nucleus. And then we have a gamma ray. Okay, gamma ray, of course most of you already know, this is the part of the electromagnetic radiation. Okay, gamma ray, so it does not have mass, it is not a particle, it's just a wave, electromagnetic wave. Okay, now let's look into the meaning of radioactive decay. So what is radioactive decay? Radioactive decay, there is a few important things that you should include in your definition for radioactive decay. First, the characteristic of the decay. Okay, what is the characteristic? Apa dia sifat proses tersebut? Okay, it is actually spontaneous and random. Okay, the process is spontaneous and random. And then undergone by unstable nuclei ataupun nucleus kan. Okay, siapa yang melalui proses radioactive decay ni? Any unstable nucleus. Okay, any unstable nucleus. And then what will happen during that process? This unstable nucleus will emit radiation. Okay, will emit radioactive radiation. So apa dia radioactive decay? Dia merupakan satu proses, yang berlaku secara spontaneous dan random. Okay, spontaneous, kita tak boleh nak jangka, we cannot predict when the process will occur, and randomly we cannot predict which nucleus will decay first. Okay, that's why it is called spontaneous and random. By the unstable nucleus, only unstable nucleus yang akan melalui proses ini. Dan apa yang dia buat? By emitting the radioactive radiation. Macam mana dia menjadi lebih stabil? By emitting, dengan memancarkan sinar radioaktif such as alpha, beta, and gamma. So that is the definition of radioactive decay. Okay, the nucleus before decay is called the parent nuclei, and the product of decay is daughter nuclei. So kita ada dua term lah. We have two term here that have been introduced. The first one is the parent nuclei. Okay, parent nuclei. So this one maksudnya yang sebelum tu lah. Okay, which is the nucleus kan. nucleus sebelum berlakunya proses decay. And the product of the decay is called the daughter nuclide. So this is the nucleus after the decay process occur. Biasanya dia akan jadi nukleus yang baru kan, elemen yang baru. Okay, the radioactive decay result in changes in the number of proton and neutron. So what will happen to the number of mass number, of atomic number? Okay. So during this process, the number of proton and neutron will be changed. Akan berubahlah bilangan proton and neutron. And of course, at the same time, the atomic mass, the atomic number, and also the mass number will be changed. Can be changed during this process because of the number of proton and neutron. Okay, here it explains again the spontaneous. Okay, we cannot predict the time when the process will occur. Okay, that's why it is called spontaneous. And okay, random. Okay, random. What is random here? Man, we cannot predict which atom. Okay, means each atom in a radioactive sample possesses the same probability. So we don't know which atom, which nucleus will decay at certain instant. That's why it is called spontaneous and random process. Okay, that is radioactive decay. Okay, type of radiation, decay, and its equation. So let's look into these three equations. These three decay process. The first one, we look into the alpha decay. The general equation of alpha decay is this one. This is how we can write a general equation for alpha decay. First, what we have here, the parent nuclide. Okay, here we use the symbol X because we don't know what is the element. If it is hydrogen, just write H. If it is uranium, just write U. If it is carbon, just write C. Okay, since we don't know, we just write X here. And then A is the mass number. Okay, if you still remember, mass number is equal to the, so mass number equals to the number of proton plus the number of neutron. Okay, that is A. And then Z here is the atomic number. So atomic number is equals to the number of proton, or it can actually use as the ID number, IC number for the element. For example, if we have 1, then we know X here is hydrogen, because hydrogen, the ID number is 1, or the proton number is 1. So as you can see here, during this is the process of decay. Okay, the arrow show the process of decay occur. So from parent nuclide, what will happen? Alpha decay, we know that it will emit alpha particle. Alpha particle, normally we can write it as nucleus of helium 42, which have 4 proton and 4 mass number, which is proton plus neutron, and 2 proton. Okay, so that's mean 2 proton to neutron lah. Okay, for actually, or we can also write it as alpha 2. Same, 2 proton, 2 neutron. Okay, 2 plus 2, so 2 neutron. So we have X here. It will emit, we know that it will emit alpha particle. That's mean the number here is 42. That's mean what will happen to A? Okay, A here will reduce by 4. Dia akan berkurang lah sebanyak 4. Sebab apa? Because 4 of the mass number already will had been eliminated, had been emitted. Okay, same goes with Z, or atom number. Atomic number Z minus 2. Why? Because 2 of the atomic number had been emitted. So that's why we need to minus 4 and minus 2. At the same time, of course lah, together there is energy will be released during this process. So here you can see that during alpha particle or alpha decay, the mass number will reduce to by 4, and then the atomic number will reduce by 2. Okay, minus 4 and minus 2. Okay, later on we will look into the example how we can solve this the equation or the problems that involve alpha decay. Okay, next, so here we have example. Okay, example already given here. So what you can see here, first we have uranium 238. Okay, 238. So uranium, the ID number is 92. Okay, if you look into your periodic table and you find uranium, atomic number is always 92. That means if you have an element that you don't know what is the element, but you know the number, the atomic number is 92, that means you can decide that this is the uranium. So boleh tahulah benda apa kan. Bergantung kepada nombor IC dia kan. Kalau 92, so kita dah tahu it is uranium. Okay, this is the atomic number or the number of proton inside the nucleus of uranium. Okay, let's say this uranium will undergo the process of alpha decay. So we know that it will emit alpha particle. So alpha particle is 4 and 2. Okay, 4 and 2. So what is the daughter nucleus here? Okay, what is the new nucleus that will be produced by emitting alpha particle from the uranium? So apa yang akan terhasil dekat sini? So before that, we can find the mass number, atomic number. So here the mass number 238, okay, 238 minus 4, and the atomic number here is 92 minus 2. Okay, so which is equivalent to this one lah, 234, and of course this one 90. Okay, 90. So what you will get here, okay, let me rewrite this number. Okay, so here is 234, this is 90. Okay, 90. So we will get a new element. Of course here the element is already given, which is thorium, but if the element is not given, so how can you determine the name of the element here? You can refer to the ID number here, 90. Okay, it is 90. The atomic number is 90. So open your periodic table and you can find that 90 belong to this element, which is thorium. Okay, so that is how we can analyze this alpha decay equation. Okay. So that's all for alpha equation.